Hello everyone, and welcome back to another episode of Math with Dr. War. Today's lesson is going to focus on what is the difference between linear and exponential functions. Let's begin. Linear functions take on the form of y equals mx plus b. Now we saw this equation before in the graphing videos, and remember the m represents your slope and the b your y-intercept. Always remember, if a function is linear, then its graph is a straight line. So your graph could be a diagonal straight line, or it could be a horizontal straight line, or a vertical straight line. We all know what a straight line looks like. If it is a straight line, it is linear. Now, on the TASC test, they may give you a group of equations and ask you to identify the linear function. Now, in order to identify whether a function is linear given an equation, you're going to focus on your x variable, and if you do not see a visible exponent, then it is linear. Always remember, it has an x with no visible exponent. So my first function here, or equation, I have y equals 5x plus 1. I'm going to focus in on the x. I notice no visible exponent, therefore linear. And when they say no visible exponent, it means you can't see a number. Now, we know from solving linear equations that here there is an exponent. It's a 1, but it's invisible. Here I have y equals a half x. I notice that here's my variable x, but no visible exponent is seen, therefore linear. 2x plus 3y equals to 6. Again, focus on the x. Notice no visible exponent, so my answer will indicate that this is a linear function. Now on the TASC test, they like to give you scenarios. So they'll give you a word problem and they'll ask you to identify if it's a linear function. Linear functions change at a constant rate per unit interval, which means that your linear function is either growing by a constant rate, such as you're adding 3 every interval, or it may be decreasing by a constant rate, which means you're subtracting 3 at every interval. So when you read your word problem, if it's changing at a constant rate, or I would say a constant value, single value, then it is linear. Sometimes they like to give you tables. If you're given a table, you know that it's a linear function if it has equal differences. We'll start with the y, and we'll look at our values to see if there's an equal difference between each interval. Now, I know some people are a little bit afraid of negatives, so I wouldn't start here at the -2 to the 1. I'll start here from 1 to 4. What's the difference between these two numbers? It's 3. 4 to 7, the difference is 3. Now, if we're going from 10 to 7, the difference is 3. Now, some people like to do the difference. I always tell students, if you can't really figure out the number, differences. So go 10 minus 7. I like to write it like this. 10 minus 7 is 3. 7 minus 4 is 3. 4 minus 1 is 3. And then here, 1 take away -2 will give you 3. 1 take away -2. Remember when you're subtracting, these two negatives will make a positive, so this is 1 plus 2, which will give you 3. So the difference is 3, and it's a constant rate, which means that it is linear. You can also look at your x values. These are also linear. So again, if you're a little bit skittish, you don't have to go with the negatives. You can start here. So we know that 0 to 1 is 1, and 1 to 2 is also 1. So notice that for the y's, you have a constant value, and for the x is also constant. Again, you can do a subtraction. So 2 take away 1 is 1. 1 minus 0 is 1. 0 take away -1 is 1. Exponential functions. Now, an exponential function is written in the form y equals a to the x. I did a previous video on exponential growth and exponential decay. In that video, I told you that the standard form for that equation is y equals to a 1 plus or minus r raised to the t. Now notice that's a little bit different from here, but not a lot of difference. Here, they're writing their equation as y equals to a times your base b raised to the x. Now, a is your initial value. Now, the b is representing either your growth rate or your decay rate. So instead of writing 1 plus or minus r, they're just writing b, which represents your growth rate or your decay rate, and they're raising it to a variable x and not a t. As long as your exponent is a variable, you're going to know that it is an exponential function. So right here, notice I said has an x as the exponent. So whenever you're given an equation and you have to decide whether it's an exponential function, look for your exponent. Here's your exponent and it's an x. Therefore, it's exponential. Here's your exponent. Notice it's an x. Exponential. X, exponential. Now, if you have an exponential graph, it is a curve. Your curve can rise or it can fall. Notice that this curve right here is falling, so we would call this like an exponential decay. If your curve is rising, then that will be an exponential growth. So this would be a decay because it's decreasing, and this would indicate a growth because it's increasing. They give you scenarios and you have to decide whether the scenario represents an exponential function. An exponential function changes by a common ratio or factor. So sometimes they use the word ratio or factor or percent over equal intervals. I'm going to tell you what I mean by ratio or factor or percent. So here I have a table and I have to decide whether it's exponential. Now you can always tell when a table is exponential because the values increase or decrease drastically. With linear functions, the increase or decrease is what I would consider subtle. They're not big jumps. Here, this is a big jump. We're starting at 8 and then we go to 56, and then from 56 to 392, and then 392 to 2,744. Now, anyone can tell from looking at these values that this is not an equal difference. That's your clue right away that this will be an exponential function. If it's an exponential function, when they say a common ratio, to find that ratio, again, you're going to look at these two numbers, and if you take 56 and divide it by 8, because that's a ratio, you're going to get 7. So 8 times 7 is 56. 56 times 7, 392, and 392 times 7, 2,744. So if you wrote it as 56 over 8, this will be considered your ratio. If you evaluate your ratio and you got 7, this will be considered your factor. And sometimes they give percentages. And you saw the percents from where we did exponential growth and decay. You should also look at the time, which is the days, which is also considered your x values, and just check to see whether they're increasing or decreasing by a constant value. So notice this is an addition of 1, 1, and 1. Sometimes you may have to check your x values. Not all the time, but sometimes. Let's try some examples. So our first question states, which situation can be modeled by a linear function? With a linear function, they are increasing or decreasing at a constant rate per interval. So one states the population of bacteria triples every day. Triple means times by 3. Now, because we're multiplying by 3, that's a factor. So number 1 would be an exponential. So we can eliminate that. 2 states the value of a cell phone depreciates at a rate of 3.5% every year. Now, because I have a percentage, that's my clue that this scenario is exponential. We can eliminate. Number 3 states an amusement park allows 50 people to enter every 30 minutes. Now, this would be a linear function because you have a constant value being added to every interval. Your interval is every 30 minutes, and every 30 minutes you're allowing 50 people to enter. Now number 4 can be excluded. A baseball tournament eliminates half of the teams after each round. Half means you're multiplying by 1/2. This would be an exponential function. So notice the difference between exponential and linear. Exponential has a multiplication factor and percentages, while a linear function indicates that you're either adding or subtracting by a constant value. Which scenario represents exponential growth? Number 1 states a water tank is filled at a rate of 2 gallons per minute. So every minute you're filling with 2 gallons. This will be considered linear, so we can exclude. Number 2, a vine grows 6 inches every week. So every week we're adding 6 inches. That will be considered a linear function. We're going to exclude number 2. 3, a species of fly doubles, which means times by 2, its population every month during the summer. Number 3 is our exponential growth. Number 4 will be considered linear because it states that a car increases its distance from a garage as it travels at a constant, and that's our keyword, constant speed of 25 miles per hour. So every hour it travels 25 miles. Last one. Which of these 3 situations given below is best modeled by an exponential function? A bacteria culture doubles times 2 in size every day. That is an exponential function. A plant grows by 1 inch every 4 days. That indicates a linear function. The population of a town declines by 5% every 3 years. Because of that percent, an exponential function. So your exponential functions are 1 and 3. Your correct answer is number 4. These examples represent tables. So the first table says which set of data represents a linear relation. So we're looking for a linear relationship. Remember, if you're given a table, a linear relationship will have a constant value, so it's increasing or decreasing. So let's focus on our y first. So we're going to look at the difference between 6 and 3, which is 3. The difference between 9 and 6, 3. And the difference between 12 and 9 is also 3. Let's check our x. The difference between 15 and 10 is 5. The difference between 25 and 15 is 10. Okay, right here, this is not a constant difference, which means A can be eliminated. Let's look at B. The difference between 10 and 7 is 3. 13 and 10, 3. 16 and 13, 3. So we notice there's a difference of 3 for the y values. Let's check on our x's. The difference between 15 and 13 is 2. The difference between 17 and 15, 2. And the difference between 19 and 17, 2. So notice there is a constant difference for the y and a constant difference for the x. So our linear relationship would be B. Let's check C and D just to see. Okay, the difference between 4 and 1 is 3. However, the difference between 16 and 4 is 12. That is not linear. If we look at D, the difference between 11 and 1 is 10. And the difference between 17 and 11 is 6. That excludes D from being linear. Which table displays exponential behavior? So remember, with exponential behavior, we are looking for a drastic increase or decrease. Let's start with A. Now if I focus on my y values, the difference between 25 and 20 is 5. The difference between 30 and 25 is 5. And the difference between 35 and 30 is 5. Now with A, it's not a drastic increase. A is linear, so we're going to eliminate that as being an exponential. Alright, let's look at B. Just going to focus on the y first, because remember, the TASC test is timed. The difference between our 10 and 8, just to make it simple, is 2. The difference between these two, 2, and this is also 2. Again, there's no drastic decrease, so we can eliminate B. When we look at C, so again, look at it. Is there a drastic increase? Is it increasing drastically? This doesn't look like a drastic increase. Again, if you look at the difference, I'm going to get my calculator. So if I find the difference between 74 and 48.5, that's a difference of 25.5. The difference between 99.5 and 74 is also 25.5. So this is again not an exponential function. So we can eliminate C. Okay, let's look at D. Let's look at our Y values. So I see 400, 125, and 6.25. Now it's decreasing, and it's decreasing kind of drastically because you start with 400 and then you go to 100. So if you actually try to do the difference, you would see that it is not equal, because the difference between 400 and 100 is 300. 125 is 75. So we know right away that that's not linear. So because it's decreasing, you're going to have a factor that is a fraction. So if you like to, you can do the ratios. So my ratio would be 100 over 400, and these zeros cancel, and I get 1 over 4. And that's my factor. Again, if you do 25 over 100, you're going to get 1 over 4. Another way you can look at it is, I know that because it's decreasing, I'm going to get a fraction, and the numerator will be 1. And then I ask myself, okay, how do I go from 400 to 100? Now I know I can't multiply because I'm decreasing. So what number would I divide by? So 400 divided by 4 will give me 100. 100 divided by 4 will give me 25. And if I took 25 and divided it by 6.25, I would get 4. Now if you don't like doing it that way, you can write your ratio. So remember, you're going to put 100 over 400, and that gave you 1 over 4. Now, if you're given equations and you have to identify whether they're linear or exponential, that is simple as well. It says, which of the following equations are linear functions? Select the 3 equations that are linear. So there are 3 here that are linear. Remember, linear functions has an x with no visible exponent. So let's look at A. Here's our x. I don't see a exponent here, so this is linear. So A is linear. Now B, I can see an exponent, so this is non-linear. C, okay, here's my x, no visible exponent. C is also linear. D, y equals to x, okay, no visible exponent, so D is also linear. E would be considered non-linear because we do have a visible exponent. I can see a 2. And F would also be non-linear because I can see an exponent. There is a visible exponent, it's a 3. Remember, when you have an equation, it is considered linear if you have no visible exponent. There's no exponent here with your x, none here, none here. This one is a little bit tricky, but remember, there's an exponent here. You can see it. It's a 2. So your answer is A, C, and D. Which equation represents an exponential function? Now remember, if it's an exponential function, you have an exponent, and the exponent is an x. So here, I don't see an exponent. We're going to eliminate A. We have an exponent here, but it's a 2. Our exponent needs to be a variable. C, I have an exponent here, and it's a variable, and it is x, so your answer is C. Always remember, you can identify an exponential function because the exponent will be a variable, and sometimes it may be an x, and sometimes it may be any letter in the alphabet. And remember, they're 26. Now sometimes they give you again a scenario and you have to pick the graph. During a decade of continuous drought, the water level of a lake has decreased by 10% each year. Which of the following graphs could model the water level of the lake as a function of time? Because it's decreasing by 10%, that 10% indicates that we are looking for an exponential function. Therefore, we can eliminate B and D because these are linear functions as they are straight lines. Another key word here is decrease. So our graph should be decreasing. Therefore, our answer is A. That's the only graph that's indicating a decrease. So our graph is falling. C would be considered an increase because our graph here is rising. Finally, I put in this last one. It states which explicit formula describes the pattern for this table. So you're given a table and you have to pick the formula or equation. Now looking at your table, notice that the values look like they're increasing and it looks like it's drastic. Now if you try to find the difference, notice the difference between 6 and 1 is 5. And the difference between 36 and 6 is 30. So right away you know that this is not a linear function. Which means we can eliminate A because this is a linear function, no visible exponent. We can eliminate B, again, no visible exponent. So our answer is either C or D. Our answer is going to be an exponential function. What do we know about exponential function? The exponent is a variable. Therefore, your answer is C. Your answer is not D because your exponent is an integer. Exponential functions have a variable as their exponent. Now, you could have written this out. There's some folks who like to. So remember the formula is y equals to a b raised to the x. A is your initial value, and remember from your exponential growth and decay, you know your initial value because you look for the 0 and then its associated value is 1. So A is 1. Now we have to figure out the ratio. So because it's an exponential, it will be 6 over 1. 6 divided by 1 is 6. 36 divided by 6 is 6. So your ratio is 6 over 1, or your factor is your multiplying by 6. 1 times 6 is 6. 6 times 6, 36, and 36 times 6 is 216. Therefore, that in the parentheses, if you choose to use parentheses, would be your 6 raised to the x. And remember, 1 times anything is itself, so it's just 6 raised to the x. Now, they didn't use x, they used d, because remember, this is your x, and this will consider your y. 6 raised to the d. And you're finished. Another way you could have done this problem is some students like to substitute. So we have C equals to 6D. So we know D is 0. So this would be 6 times 0 is 0. But that's a 1. You have C equals to D plus 6. So if our D is 0, 0 plus 6 is 6. Okay, that's a 1. So that's eliminated. You have C equals to 6 raised to the D. Now, if your D is 0, that's 6 raised to the 0. And remember from exponentials, anything raised to the 0 power is a 1. Let's try it over here. Suppose our D is 1. So we'll have 6 to the first power is 6. 6 to the second power is 36. So if you don't want to, you can plug in the values into each equation to figure out which answer it is. I hope these examples have been helpful. Good luck in your TASC examination. And remember, if you like the content, please like and subscribe.